In the last session, we have discussed the various sampling methods. We saw that there are major two sampling methods, that is probability sampling and non-probability sampling. We saw the different types of probability sampling as well as the types of different non-probability sampling in the last session. So today we'll be discussing about the sample size. What is sample size? How do we determine the sample size? What are the different considerations while selecting a sample size? That we will be discussing. So first of all, we'll understand what is sample size. So it is the sample size is a subpopulation, a portion of the population we will be studying in order to make an inference to a reference population. So from a population, we take few portion or few sample which we study so as to make an inference for the total population. There can be a census study. Census study means the study wherein we include uh, all the subjects or all the units of that particular population in that study. So in census, you will see that the sample size is equal to the population size. So we take the entire population as the sample. However, you will see that in research, we have time constraints as well as budget constraints, and therefore a representative sample we are normally using for conducting a research, and then on doing research on that particular sample we infer the results over the total population. So the larger the sample size, more accurate findings we'll get. If we are doing a census, then the results will be more accurate. So the larger the sample size, there will be more accuracy for the study. In sample size determination, the sample size determination is a mathematical estimation. Mathematically, we estimate the number of subjects or units which can be included in the study. When we have a representative sample taken from a population, the findings are generalized to the population. So when we have a sample which is a representative of the population, then whatever findings we are getting, we can generalize it to the population. Generalize means we can apply it to the population, and therefore optimum size of the population is very important, and that optimum sample size is required for different reasons. The first reason is to allow for appropriate analysis. So if the sample size is optimum, the best possible adequate sample size is there, then we can have an appropriate analysis over that. Then to provide desired level of accuracy. So if the sample size is optimum, then it can provide desired level of accuracy to the findings and to allow validity of significance test. So whatever tests we are using, for those tests minimum number of sample size is required. So to allow that test to be conducted on that particular sample, we have to have an optimum size of the sample. Are you getting this? Are you clear about this?
Yes, sir.
So while we are talking about sample size, if the sample size is too small than the required, then the conducted study may fail to answer the research questions. We will not be able to answer the research question. It may also fail to detect the important effect of association. So whatever associations or relationships we want to measure between the various variables, that we will not be able to detect properly. On the other hand, if the sample size is too large, then the study will be difficult as well as it will be costly. There will be time constraint, more time will be required if the sample size is large. And if the sample size is more than required, if it is too large, it will also lose the accuracy of the results. And therefore an optimum sample size must be determined before commencement of any study. So before starting any study, an optimum level of sample size need to be determined. Optimum means the maximum possible sample, or the best suitable sample for that particular study need to be selected. It should not be too large, it should not be too small. Going ahead, before we discuss the different criterias for determining the sample, we need to understand a few basic concepts like variance and standard deviation. Have you heard these terms, variance and standard deviation? Have you heard these terms, variance and standard deviation? Simran, Mohit, Yogesh?
No, sir.
So we'll understand first what are these terms, variance and standard deviation, so that we can understand these terms whenever these are coming in our discussions ahead. First of all, the variance. What is variance? Variance is average of square differences from the mean. So we have to have a mean. Mean means the average of the all the numbers. If you have 10 numbers, if we add all those 10 numbers and divide it by 10, we will get the mean. So mean means average. So it is, variance is average of square differences from the mean. And standard deviation is a quantity which expresses how much the members of the group differ from the mean value of the group. Standard deviation is, it is a quantity or number that will show how those members of that particular group differ from the mean value of the group. It is also the square root of the variance. So if you have square root of variance, you will get standard deviation. So to understand these concepts, variance and standard deviation, we will have one example. Before that, we will understand how we calculate variance. So as we said, variance means it is the average of square differences from the mean. So we have to have first the mean, and when we have mean, we have to calculate the differences of all the members from the mean. We have to make a square of all those differences from the mean, and then we have to make an average of all those squared differences so that we can get variance. So this is a procedure to calculate variance. So first of all, as I said, work out the mean. First of all, calculate the mean of the numbers, the simple average of the numbers. Then for each number, subtract the mean and square the results. So that means calculate the difference of each number from mean, and then make a score of that, and then do the average of all those squared differences. Then calculate the average of all those square differences. First of all, you calculate the mean, then for each number you calculate the difference from the mean and make a square, and then make the average of all those differences. That will give you variance. So variance is squared means square differences from the mean. So it is the total of square differences from the mean value. We will take the example so that you will understand it better. Are you able to see this picture? Yogesh,
Yes, sir.
Simran.
Yes, sir.
Yes.
So in this picture, you will see that there are different breeds of dogs having different heights. So here we have the heights which are measured at the shoulder of each dog. If you see this diagram, in this diagram, these red arrows which we have shown, red pointers, that will show the height of each dog. So here for the first dog this is the height, for the second dog this is the height, for this third this is the height. So for each dog we have marked the height of that particular dog, and these heights are measured in millimeters. 600 mm, then second is 470 mm, third is 170 mm, fourth is 430 mm, and fifth is 300 mm. So likewise we have the height of each of the dog. So these are the numbers we have with us: 600, 470, 170 mm, and 430 mm, 300 mm. These are the numbers we have, group of breed of dogs having different heights, and these numbers we have 5 members in this group. Each is having different height. So we'll first calculate the mean. Mean is sum of all the numbers divided by total numbers, that is 600 plus 470 plus 170 plus 430 plus 300, and then divided by total members of that particular group, that is 5. So it comes to 394. So the mean of height of all these breeds of dogs is 394. Are you getting how we have calculated mean?
Yes, sir.
So then if you see the diagram, first of all see this diagram. In this diagram you will see that we have marked this mean by this green line. So this is a mean 394 for this particular group. This 394 we have marked it as a green line over this diagram. So that shows the mean value of this particular group. Now our second task is to calculate the difference of each member or each number from the mean value. So if we calculate the difference of each number from mean value, we get 206 for this first number, 76 for this second number, minus 224 for this third number, 36 for this number, and minus 94 for this fifth number. So once we have mean, we have calculated the difference of each number from the mean. Are you getting till this?
Yes, sir.
Yes, sir.
So now we will calculate the variance. The variance means the squared average of the difference from the mean. So these are the differences from the mean: 206, 76, minus 224, 36, 94. These are the distances from the mean, and we are making a square of it. So square of 206, square of 76, square of minus 224, square of 36, and square of minus 94, and we will divide it by total number because we want average. As per the definition, this variance means the squared average of difference of each number from the mean. This variance will be denoted by sigma square. This sign is called as sigma. Sigma square is called as variance. So if we calculate these squares and we add it and take average, we get the value 21,704. 21,704. This is the variance for this particular group. Have you understood how we have calculated the variance?
Yes, sir.
So variance means the squared average of difference from the mean. Now we will calculate the standard deviation. Standard deviation, as per our discussion, standard deviation is denoted by sigma, and it is the square root of variance. So simply, if we have square root of this number 27,704, which we have got as a variance, if we have square root of this, we will get the standard deviation, that is 147.3. we will take the nearest value, that is 147. As a round figure, we take the 147, and that is a standard deviation for this particular group. So now we will understand what this standard deviation means. So in this diagram, which we will see, this green line is showing the mean, the 147 which we have got, the standard deviation, that is 147 which we have got on both the sides. If we mark that 147 standard deviation from this mean, we will have these blue lines, this one blue line on the upper side and one blue line on the lower side. So we'll have this range of standard deviation 147 on both the sides, from where we can understand what is the standard deviation for this particular group. And if any value is going beyond this standard deviation which is calculated for this group, we can say that it is extreme. It is either extra large or it will be extra small. So in this diagram, you will see that this first dog has extra large height, which is going beyond the standard deviation of 147. And in this diagram, you will see that the height of this dog, which is going below this standard deviation, so it is extra small, or it is small than the standard deviation. So standard deviation will tell you the standard deviation of the numbers from the mean. From the mean, how much standard deviation is expected for the members in that particular group, that will be told by your value of standard deviation. Have you understood till this?
Yes.
Any query in this? Any query?
Yes.
So we have understood what is variance, what is standard deviation. So now we'll go ahead and we'll discuss about the sample size criteria, or these are the few points that need to be understood for calculating a sample size for particular population. These are the few factors which need to be taken into consideration for calculating the sample size. These criteria may be the level of precision, level of confidence, or it can be called as level of risk, or third is degree of variability. So these three criteria we will understand in detail. The first criteria is level of precision. Precision means accuracy. How accurate the results are expected. So this level of precision will tell you the range in which the true value of the population is estimated to be. So how much accurate the results should be, or how much accurate the results are, that range will be told by this level of precision. And this range is often expressed in the percentage points. For example, we have plus minus 5%. So we take example so that we will understand what is level of precision. So if we take an example of a researcher who is studying farmers, and he finds that 60% of the farmers in that particular sample size have adopted and recommended practice with a precision rate of plus or minus 5%. So there are 60, he find that 60% farmers in that particular sample have adopted particular practice with a precision rate or accuracy rate of plus or minus 5%. Then he may conclude that the actual result or actual percentage of farmers that have adopted this particular practice may be between 55 to 65. So instead of saying 60% farmers, as his precision rate or accuracy rate is plus or minus 5, so he will add and subtract it. He will take the range between 55 to 65%. So he may conclude that the 55 to 65% of the farmers in that particular population have adopted the particular practice. Are you getting this? Is it understood? Pallavi?
Yes, sir.
So level of precision means the accuracy, which will be always denoted by percentage point between plus or minus 5%. For it is, for example, it may be plus or minus 3%, plus or minus 1%. So it is a range between the findings or result which the researcher want to conclude that between this range the actual result will be. So instead of saying only 60% farmers have adopted this practice, he will say the 55 to 65% farmers have adopted this particular practice. The second criteria is confidence level. So confidence level, that means the percentage of all the possible samples that can be expected to include the true population parameter. Population parameter means it is some number about the population. Maybe we take mean. So confidence level is the percentage of all the possible samples that can be expected to include the true population parameter. So if we take a repetitive sample from a particular population, for example, if there is a particular population and from that population we take repetitive samples. So here is the percentage of all those possible samples that are expected to include the true population parameter. So it is expected that all those samples which we have drawn from that population have that characteristic of the population or have that number which is representative of that particular population. In a normal distribution, approximately 95% of the sample values are within two standard deviations of the true population value. For example, mean. If we see this diagram, are you able to see this diagram?
No, sir.
Is the diagram visible? Hello?
No, sir.
Yes,
No,
sir.
sir.
Yes, sir. Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay. So this diagram, you will see that this is a normal distribution curve for population. For population mean. Here population mean means mu. This sign is mu. Here we will, this population means is signified by a symbol that is mu. So in this diagram you will see that this line is a particular population mean for that particular population, and these are the deviations from that particular mean on the both the sides of this mean. And in normal distribution, you will always see that that is equally distributed among both the sides of the mean, and there will be extreme values. This darkened spot or darkened shaded spot you will see at the tails of this particular graph. This shaded part is extreme values, those which are beyond that particular standard deviation. We'll go back to the diagram which we have some time back referred for standard deviation. So if you remember this diagram, in this standard deviation of 147 on both side, we have seen that there are some extreme values. There may be extra large or extra small values which are called as extreme. So these, if they are plotted on this graph, it will look like this. The mean value will be at the center, and all those values of sample mean will be distributed on the both side of this mean equally, and this diagram or this graph will look like a bell-shaped curve. This graph will be a bell-shaped curve, wherein you will see that these two limits on the both side and this area which falls below this bell curve are all the values of the sample which correspond to the population mean. So this area is approximately 95%. So 95% of the sample means within two standardized deviations that fall under this bell-shaped curve. Have you understood this bell-shaped curve?
Yes, sir.
So in other words, if you want to say, this means that if 90% confidence level is selected, so this normal curve, normal bell-shaped curve, you will see that 90%, 95% of the sample means will be within the standardized limit, within the standardized deviations. So for 95% confidence level, if it is selected, we can say that 95 samples out of 100 samples will have the true population value within the range of that precision. So if 95% confidence level is selected by the researcher, he can say that if we select the sample 95 times from that particular, if he selects the sample 100 times from that particular population, at least 95% of the samples will have the value which is equivalent to the population mean. Is it clear till now?
Yes, sir.
Yes,
Going ahead, we'll see the another criteria or another factor which we need to take into consideration while sample size determination is degree of variability. So how the population, how the subjects or the items in that particular group vary from each other. So this degree of variability will denote the distribution of attributes in the particular population, may it be a gender or may it be the height, how that attribute is distributed in the population. So there may be, based on this distribution of attributes in the particular population, there may be a homogeneous population or there may be heterogeneous population. So in heterogeneous population, you will see that the variation is more. The most of the subjects will be different from each other. Therefore, the more heterogeneous population will be there. So if the population is more heterogeneous, we need to take a larger sample size for better precision or better accuracy of the results. And if the variability or the difference in the different characteristics of the population or the subjects in the population is less, if the sample is less variable, that is more homogeneous, then we can take smaller sample size. More the heterogeneity, more population, more sample size we need to have more accurate results. If there is less variability or more homogeneity, we can take smaller sample size for having accurate results. Usually this degree of variability will be shown as a value that may be 0.5. Here in this case we take this proportion of 0.5. 0.5 is the value which indicates maximum variability in a population. So conventionally this 0.5 shows more heterogeneity in a particular population. Value below 5 or more than 5 may be more homogeneous. However, 5 is the maximum variability in that particular population, and therefore we take 0.5 as a value for degree of variability when we want to take a more conservative sample size. Conservative means more conventional, more suitable sample size for particular study. So we usually select 0.5 as a proportion of variability or degree of variability for particular samples. Have you understood?
Yes, sir.
Going ahead, we will see what are the different strategies for determining the sample size. While determining a sample size, we can have different strategies. By different ways, we can have sample size. Sometime making use of census for small populations. If the sample size, if the population is small, maybe like 200, we can study all the units in that particular population. So we can have a census of all that population. So making using a sample for a small population may be one of the way of having a sample size. Second strategy or second way of having sample size is using a sample size of a similar study. So if particular if other researchers has done some similar study which the researcher is conducting, then he can have sample size which the other researchers have taken for their research. However, those errors, those they have incurred, that may also come in your study. That may be the disadvantage of this method. Then third strategy for determining the sample size is using the published tables. We can have published tables for determining the sample size. In this published table, for example, you can see this sample sizes are given for particular size of population. So here we have taken this table has taken three criteria: the precision levels plus minus 3, plus or minus 5, plus or minus 7, plus or minus 10%. All these are precision levels. How accurate the results are desired by the researcher. These levels are given. Confidence level is 95% for this particular table, and P, that is variability, that is the variability is 0.5. As we have discussed, if there is maximum variability we expect, then we can select 0.5 as the degree of variability. So here P is 0.5. So as per this table we can select sample size for particular population. So for example, here if the population is 6,000 and if we want plus minus 3% precision level, we can select 938 subjects or 938 individuals for the particular study. So calculating sample size from the table is very easy. We can just refer the table and we can see the corresponding sample size in front of that particular population size. So for particular population size, the sample sizes are given based on the precision level, the confidence level, and the degree of variability. Have you understood this using published tables? Yogesh, Vinod,
Yes, sir.
Vinod. Going ahead, we will understand how we determine the sample size from different formulas. So strategies for determining the sample size from the formula. We can have formulas to calculate the sample size also. So this is the first formula which is which is designed by Cochrane. So this sample size formula, which is for populations that are large. When the population size is large, Cochrane has developed an equation which can give you the size of the sample. So this equation is 90 is equal to z square pq divided by e square. So here in this example you will see n0 is the sample size which you want. Z is value of the given confidence level. Z is the value you can take from the table confidence level to Z score table. So here you can see for 95% confidence level the Z score is 1.96. So you can take 1.96 as a Z value. E is the desired level of precision. So the precision level we saw that it may be +5 to -5. So if precision level we have selected plus or minus 5 percentage, then to convert it into decimals, we can have 5 divided by 100, that is 0.05 is the value of E for this. Then we have P in this equation. P is the estimated proportion of the particular attribute present in that population. Based on the variability or the heterogeneity, we take maximum heterogeneity most of the time. So we can take 0.5 as a value of P in this equation, and Q is simple. Q is 1 minus P. So if P is 0.5, Q is equal to 1 minus 0.5, that is again 0.5. Are you understanding this? Yogesh, Pooja, Kalyani, have you understood this formula?
Yes, sir.
This is the formula which is for proportions. When populations are large, we can use this Cochrane's formula to calculate sample size. Another formula which we have, which is a formula for mean. So the earlier formula which we have seen, wherein the responses will be dichotomous, that is, wherein the responses will be of in the two options, yes no type, that is dichotomous. So for those type of responses wherein the responses are dichotomous, you can use these formulas. However, if the responses are polytomous, that means it is more than two options or more than two options for that response, then this type of formula can be used. So this formula is also simple, which says that 90 is equal to z square sigma square divided by e square. This is also a similar formula wherein n0 is the sample size, z is the value for that particular confidence level which can be taken from the table. E is the desired level of precision which we have just discussed in earlier formula, and sigma square, this sigma square is the variance. We have discussed how we calculate the variance. Variance is the square averages of difference from the mean. So that value you have to calculate and you have to put it here. So this formula says n0 sample size equal to z square sigma square divided by e square. Okay. Have you understood this simple formula? Yogesh Pallavi?
Yes, sir.
Yes, sir.
So we'll just have a quick review of what we have discussed today and then we'll stop. So in today's session, we have discussed the sample size. What is sample size? What are the different parameters or different factors need to be taken into consideration while determining sample size? That we have discussed. Those parameters or those criteria are level of precision, level of confidence or risk, and degree of variability that we have discussed. Then we discussed the different strategies or different ways of determining the sample. We saw that the sample size can be determined on the basis of census of all the population. We can make use of sample size of other similar study. We can have published tables and we can calculate the sample size from the different formulas. Is it okay? Have you understood till now? Any query in
Yes.
this?
No, sir.